Hello everyone, welcome back to my channel. So today we'll be talking about a problem on linked lists. So let's first take a look at the problem statement. You're given two non-empty linked lists representing two non-negative integers. The digits are stored in reverse order, and each of their nodes contain a single digit. Add the two numbers and return it as a linked list. You may assume the two numbers do not contain any leading zero except the number 0 itself. So basically, for the input of this question, you're given two nodes that represents the very least significant number, and these nodes lead to two different linked lists. And these two linked lists represent two non-negative integers, and your task is to basically add these two numbers. The important part of this question is that these two linked lists, they are in reverse order. So if you want to add 123 to 456, then the linked list you're given is 3 pointing to 2 pointing to 1 plus 6 pointing to 5 pointing to 4. And these inputs being in reverse order is actually easier for us to solve this question in code. Because if we think about it, in real life, if you're adding two numbers manually, right, we always start from the least significant digit, which is the digit on the very right-hand side. So since these two numbers are in reverse order, that means if we go from the very beginning of the linked list to the very end of the linked list, it is automatically in the order of from the least significant digit to the most significant digit. So this way, if we encounter a carrying, then we could just move the carrying with our pointers from the very least significant digit to whatever's next to it. So the idea of solving this problem using code would be simply using two pointers, one starting from the first linked list's head and the other one starting from the second linked list's head. And basically we're just going to move these two pointers to the next node of your current node while adding your current node's value together. And while you're moving these two pointers to the next node, we need to keep track of the carrying. And as long as we've reached both nodes' end, or like both linked lists' end, then that means we have added all digits, so we are done with the calculation. Alright, so now let's take a look at how we could actually code this solution out. Well, so the first thing that we need to think about is, since we're traversing from the very end of these two numbers to the very front of these two numbers, and we are calculating our result on the run, we definitely will need a separate node to store the result. And we actually need two pointers to that node, to the result node, because since we're traversing while calculating and recording the result, if we only have one pointer, then once we are done with these two linked lists, our pointer is definitely going to be pointing at the very last element in our result linked list. So we will be using another pointer to point at the head of our result linked list, so that once we're done with calculating the addition of these two numbers, we could just simply return that head pointer. Another thing is, since we are calculating on the run, we will need a dummy head. So at the end of this solution, instead of just simply return our head pointer, we're actually going to return the next node to our head pointer. So the first step, I am going to make a dummy head and also a temp pointer, and these are going to be just brand new list nodes. for the temp pointer, we're going to use that to traverse through our result while doing the calculation. And then we're also going to be needing another variable called carrying, because we'll be calculating the carrying and then we'll be carrying the carrying throughout this traversal. And then we're gonna need a while loop, while L1 or L2. So this basically means whenever like both of these nodes are null, that's when we're gonna stop. Because when both of these nodes are null, that means we have reached the end of these two linked lists. And then we'll be getting the value of these two nodes. So val1 equals l1.val, and here we need to pay attention to, since this is while L1 or L2, so there is a chance that maybe L1 is null in this case. So we need to check if L1, meaning if L1 is not null, else we'll just pass in 0 for our val1 variable. And then similarly, we're going to do that for our val2 variable, if L2 else 0. And then we'll calculate our current sum, which is going to be val1 plus val2, and also don't forget about our carrying. And then we'll be creating a new node. Let's just call it node, and this node is going to be carrying the value for our current sum, or like it's going to be carrying the value for this current digit. So we are going to be creating a new list node, and here we're going to pass in its value. So its value is going to be current sum. We're going to get the mod of this current sum because we want to have just one single digit for this position. So mod 10. And we're also going to be updating our carrying, which is going to be current sum divided by 10. And then let's now think about how we could basically connect this node to our dummy head, because we know that we are going to return the next of our dummy head, and we're using the temp pointer to traverse through the result. So basically temp.next will be pointing to our current node. And then since we're traversing through the result, we're definitely going to be updating our temp pointer. So temp is going to be temp.next in this case. And then after we've updated our temp pointer, we also need to update our L1 and L2 pointers so that the while loop could stop eventually. So L1 is going to be L1.next, and also we need to check if L1 is not null, else we just do none. Similarly for L2, if L2, else none. Alright, so once we've finished writing this while loop, let's think about, like, after the while loop is done, is there anything else that we need to pay attention to? The answer is yes. So the thing that we need to pay attention to is that there could be a chance where after the while loop is done, you still have a carrying at the end, right? So what we need to do is to also add a new node to the very end of our result linked list that contains the value of our carrying. There are a couple ways to do this. One way is right here you could do if carrying. So if we do have a carrying, then we create a new node that contains the value of the carrying, and then we're going to be pointing our temp.next pointer to this node, which is basically what we have done inside of this while loop, which means to make the code cleaner, we could definitely change this line. So the condition for our while loop, we could add another or clause, which is or carrying. So if we still have either L1 is not null or L2 is not null, or we have a carrying, then we continue running through this while loop again. So this way we could delete this part, and the while loop would handle all these cases. And at the end of the function, we're going to be return our dummy head dot next, because our dummy head is basically, well, it's clearly a dummy head, so it doesn't really contain anything that is useful for our return result. But the next of our dummy head is actually the actual head that we need after doing the calculation. All right. So now let's talk a bit about the runtime and the space complexity. So for the runtime complexity, if we look at this while loop, the total number of loops that we're going to run through in this while loop is going to be the maximum number of either L1 or L2, because our pointer that runs through L1 and the pointer that runs to L2, they basically move forward together. So whichever one's longer, whichever linked list is longer, will be the number of loops that we're going to be running through this while loop. So the total runtime would be big O of max m or n, m being the length of the first linked list and n being the length of the second linked list. And for the space complexity, since we're creating our result linked list, and our result linked list is going to be containing the maximum number of digits among the first linked list or the second linked list. So our space complexity is going to be big O of basically max m or n. This is the first linked list related problem I've ever done in my channel, and I'm hoping to do more videos on questions related to linked list, because linked list is also a very common question subject showing up in interviews. And that completes my video for today, and I hope to see you in my next one. Bye!